computers, not all computers created equal, right? So we should have, in order to be more efficient, we should have computers that can do storage, or some computers to do communication, and some computers that does processing, right? We don't have to make all these computers the same to create the supercomputer. We can have one set of computers that are good at doing one thing, and another side of computers that are good at doing something else. That way, we can also create a supercomputer, but it can do a lot more complicated work. And actually, that is the concept behind Moac. Moac, M-O-A-C, is a blockchain that has a sub-chain architecture where you can have multiple chains, and every chain will be dedicated to do something that's different. This is also a company that's in the Bay Area. Their headquarters is Palo Alto, and they started. I think they had a very successful ICO last year in June, and right now I think they just released their testing network last month. So what I want to talk about is how to implement an IPFS chain that is used for storage on one of the Moac subchain. So in order to do that, first I need to walk you over the subchain architecture of Moac. Lots of information on this one. I'll try to be slow, and feel free to ask me questions whenever. So on the bottom here, in blue, we have the P2P network, which is the same for all different blockchains. You need to use a P2P network to communicate with each other. And then the arrow, you can consider that as a blockchain. And then all the nodes, the blue nodes, are the main nodes. Those are the nodes for you can say for the main chain or for the mother chain. And these are called V nodes. They're doing the POW work, and they are making sure the whole blockchain is stable. Now everything in blue looks very similar to Ethereum. The only difference is that for Moac, it's recommended to only run transactions on the main chain. Why do I say recommended? Because you can still run contracts on the main chain, but you will have to pay more. So the payment structure is changed, so you don't run the contracts on the main chain. So now we all know the Ethereum was great, but there's a huge problem with Ethereum is it's too slow. If you run contracts, it could take the system down. For example, the famous CryptoKitties. That game actually is taking the system down multiple times because it's taking a long time to run those contracts. If you take the contracts out of the main chain, it'll be fast, right? That's very easy to understand. So Moac can actually run like thousands of transactions per second. How many transactions can Ethereum run? 25. So that's a huge boost. But that's not the secret sauce of Moac, because you still have to take care of the contracts. So who's going to take care of the contracts? The subchains. So this whole structure is to support a way to run only balance transfer transactions on the main chain, and then run all the contracts on the subchain. You can have multiple contracts running on the same chain, or you can basically create a subchain for every contract. However you want to do it, this whole system is supporting it. So how was the subchains created? Now, the main chain and the subchain have slightly different nodes. The main chain nodes, the V nodes, needs to do POW. That means you need fast computers, GPUs, ASIC, to run the mining. But for the subchain, they don't have to do that. So that means you can have commodity computer to do it, or you can even use your cell phone as long as you keep it 24/7 online. So that is the secret sauce behind Moac is for the main chain you are able to do mining and make some money, but on the subchain you don't have to do mining, but you get paid by executing contracts because you get gas, right? And in order to make sure these subchains are secure, these subchains, the green ones, they don't talk to each other. How do they talk to each other? It goes through the main chain. That is why there's an arrow from every green dot to the blue dot, because you have to talk to another nodes are on the same chain through the main chain. So that is very important because on the main chain you could have tens of thousands of nodes, and in order to tackle this whole network, you have to tackle basically 5,000 nodes. That's near impossible, right? But on the subchain, you could have, say, just 100 nodes. And if you want to tackle 100 nodes, you only tackle 51, and it's more possible basically. So that is why if we don't let the subchains talk directly to each other, then they'll be more secure because you don't know where your peers are, and it's hard for you to find a target. So, and of course, this is basically a architecture that supports that was designed for dApps. We all know that blockchain has 3 phases now. Blockchain 1.0, which is Bitcoin, took care of balance transfer. And blockchain 2.0 is Ethereum. It's doing smart contract. And Moac is considered the blockchain 3.0, where it's designed for a fast processing contract that supports dApps. Basically, it's a blockchain for dApps. And it's supporting all kinds of dApps because every subchain can be different. And as you can see, I listed here one of the POS chain, one of a DPoS chain. So because the consensus can be different on the subchain, you can actually use the same chain to support a public chain or private chain or confederate chain. So I listed out all the features of Moac in red here. Number 1 is sharding. What is sharding? Say we have tens of thousands of nodes for Ethereum. They all have to do the same thing whenever you execute a contract. What if we can break them down into smaller pieces? Say if we have 10 different groups of nodes of 1,000 each, then you can actually run 10 processes at the same time. So that's 10 times more. So that is sharding, and in Moac, it's implemented. And multi-layer, what does multi-layer mean? So if you created shards among the blockchains, you're able to do 10 different things at the same time. But they are the same type of things. You can do different things. But with the multi-layer, you can actually do 10 different things because every subchain is different. Swappable consensus. I already said, every chain can have a different consensus, so you can use for different things. Fast transactions, because you have all these subchains, everything will run a lot faster and smoother. Asynchronous contract execution. So now you have multiple chains to run the contracts. The contracts can be executed at the same time, and they don't have to wait for the other one to complete. So basically, asynchronous means you don't have to wait for one to stop and to start another one. They can start now, another one start, another one start. All right.